Hello friends, this is another question from Resnick Halliday's 10th edition. This is from the chapter Linear Momentum and Center of Mass. This is problem 9 and the question reads, a stone is dropped at t equal to 0. A second stone with twice the mass of the first is dropped from the same point at t equal to 100 milliseconds. How far below the release point is the center of mass of the two stones at t equal to 300 milliseconds? And the part B reads, how fast is the center of mass of the two stone system moving at that time? Now, let us first locate the center of mass after t equal to 300 milliseconds. For that, we need to know the distance traveled by the first stone in 300 milliseconds. Suppose the stones were dropped from here and the stone stone 1 covers S1 distance in 300 milliseconds. So we can calculate S1 as equal to half AT square because its initial velocity is 0. So half 9.8 into 0.3 square, and this comes out to be 0.441 meters. Now the stone 2 is dropped after 100 milliseconds, so it travels S2 distance in 200 milliseconds. So we can calculate S2 as half 9.8, that is acceleration due to gravity, into 0.2 square, and this comes out to be 0.196 meters. Now we can take the position from where the stones were dropped as origin, and the y center of mass from this point, from the release point basically, is given by m times S1 plus 2m times S2 divided by m plus 2m, that is 3m. mm gets cancelled, and putting the values of S1 and S2, you will get y center of mass as 0.277 meter. That means the center of mass is located 0.277 meters below the release point somewhere here. This answers the part 1. Now let's come to the part 2. Part 2 say that we need to find the velocity of center of mass after t equal to 300 milliseconds. So we have the expression y center of mass equal to m times S1 plus m times S2 divided by 3m. This is 2m. Now if I differentiate this, I'll get dy com by dt equal to mm gets cancelled on right hand side, and we'll get ds1 by dt plus 2 ds2 by dt divided by 3. So if you see, dy com by dt is basically the velocity of center of mass. So we can say that v center of mass is equal to ds1 by dt is the speed of stone 1 at t equal to 300 milliseconds. Let's represent it by v1 plus 2 times ds2 by dt is the velocity of second stone at t equal to 300 milliseconds. So that is dv2 divided by 3. Now we need to just calculate v1 and v2. Now v1 is given by 0 plus 9.8 times 0.3, which comes out to be 2.94 meter per second. Similarly, v2 is given by 0 plus 9.8 times 0.2, which comes out to be 1.96 meter per second. And if you put these values in v1 and v2, you'll get the velocity of center of mass, and that is basically equal to 2866 meter per second.